first, let's discuss these two words here in mathematics. What is an equation versus what is an expression? Ah, very good.
And it includes people or it's basically like the solution or like solving
No, actually,
people.
yes, that's the big thing. Basically, the big difference is this. That's the big difference. So expression is simply a statement. Is you're only simplify. By combining like terms. An equation you solve. You solve for a variable. And more importantly, an equation is a statement of equality between two expressions. A variable can represent anything. Once it is defined. For example, x plus 2 equals 5. By getting rid of the 2 and isolating the x, we know that x equals 3. But a variable can also equal an equation. Or a description, an item. It doesn't have to be a number. It could be anything you define it to be. Hence the word variable. It varies. It could be whatever you want it to be. Typically, we use two variables in we use two variables in linear algebra. X and Y. Because they relate to the horizontal and vertical axes of a graph. And we call that graph, that system, the Cartesian coordinate system. Which we'll talk about that at the last section of this chapter. All right. Identifying variables in a math statement. The cost of renting a car for any number of days is at $40 per day. What is the variable in that statement? Yeah. Number of days. Why is it number of days? Yeah, because by definition, variable means it changes. So the cost equals $40 per day. The more days you have it, the more you have to pay. The distance traveled by a car at a constant 65 miles per hour for any number of hours. So what's the variable? Anybody else who has not answered it? Right. So the variable is number of hours. Because distance equals rate times time. So the distance traveled is 65 miles per hour times X number of hours. So if you think about it, if I have 65 miles per hour and I travel for 3 hours, what is that going to find for me? Oh,
65.
65 times 3 is what? 195. But look what happens here. We have hours here and miles per hour. So the hours cancel. All we're left with is the miles. So that's the distance. And so it's very important in mathematics. We have to be very conscious about our units. Sequences. What is a sequence? What do you mean a pattern? That's a pattern. It's tessellation, a bunch of squares. That's not a sequence. Occurs multiple times? No. A sequence is a list of values that are all related by either a an algebraic constant or a geometric ratio. For example, how are these numbers related? Okay, they're all odd, but is there a formula we can define them? Right. So we have a beginning term. The first one we call a sub 0. And the next one is a sub 1, a sub 2, and so on and so forth. We look for if it's algebraic, if it's, let's say, arithmetic, then there is a common difference between the terms. What does difference mean? How do we find difference? Right. So the difference, let's call it D. The difference between 1 and 3 is what? How do we find that? We go 3 minus 1. It equals 2. Between 5 and 7, it's 7 minus 5, which is 2. So the difference is always the bigger one minus the smaller one. in a sequence next to each other. So you notice the difference between all of these, between 1 and 3 is 2. Between 3 and 5, 2. Between 5 and 7, and so on and so forth. So our common difference is 2. And our instead of it, our first point, a sub 1, the first point, the first number in our sequence is a sub 1. To find the nth value of our arithmetic sequence, we use the formula start with the beginning one, n minus 1 times d. N is the location number. D is the common difference, which is a n plus 1 minus a sub n. A sub 1 is the first term of the sequence. So let's see, for example, what if I wanted to know the fourth term? So n is 4. That's my fourth term. So the fourth number is a sub 1, 4 minus 1 times d. What is a sub 1? The first term in our sequence is 1. So it's 1. What's the difference between each of our numbers? 2. 4 minus 1 is 3 times 2. 1 plus 6 is 7. So the fourth number in our sequence, the fourth term in our sequence is the number 7. 1, 2, 3, 4. Sure enough, it is. This way, you can find any sequence number you want to. Just tell me what number you're looking for, and I'll put it in there, and I'll find it. As long as we have a common difference. A geometric sequence has a common ratio between the successive terms. So let's say the first term is 2. And the next one is 4. The next one is 8. The next one is 16, 32, and so on and so forth. To find the common ratio, R, take n plus 1 over a sub n. So take the bigger one, put it on top, and the number before it, put it on the bottom. So for example, if we have a sub 2 on top, a sub 1 on the bottom, the ratio is 2. If we have a sub 4 on top, which is 16, and the number before it is 8, we also get 2. So the common ratio is 2. And the first term in our sequence is 2. To find the nth term of a geometric sequence, we use this formula. Why is it multiplied? Why is this an exponent?
The same as an exponent?
Well, it has to do with going down the line. Since the ratio is the same in each one of these, so from this one times 2 equals that. This one times 2 equals that, times 2 equals that. So each number I go further down is 2 times 2 times 2 times 2. So that becomes 2 to the power n eventually, or n minus 1. I'm going to stop at this one. So since this is, for example, if I want to know a to the a sub 4, so I want to know what number is in the 4th location, and I know my ratio is 2. Then I use this formula. A sub 1 is the first term, which is 2. The ratio is 2. 2 to the third is 2 times 2 times 2, which is 8. Times 2 is 16. So the fourth term in my sequence is 16. And sure enough, it is. All right, let's look at an example here. In an arithmetic sequence, the second term 11 and the fifth term 23 find the 100th term. So how do we do that? It's arithmetic, so we know we have to use what formula? Do we know anything else from this? Okay, so we know the fifth term is 23. We know the second term is 11. So what do we do with this?
First.
Well, do we know the D? You can't find something if it has two unknowns. So we have to first find a known. What do you think we should do? Okay, so let's see. D is equal to AN minus A1 over N minus 1. Okay. So which of the, all we did was solve for D. We still have a problem here. We don't know what A1 is. How can we figure this one out? Okay, let's see how that will work. So we don't know this one. We know it's 11. This is 1, 2, 3. Okay, so if we know this, we know what we do.
You subtract 23 by 11.
Twelve.
And divided by 2.
Is it 2 or is it 3? We're going from the second to the fifth. Isn't that 3 numbers? Which one will work better? Well, let's see. But if we add 4, 11 plus 4 is 15. 15 plus 4 is 19. 19 plus 4 is 23. So our distance is 4. So our D. We now know our D. Yeah, so that's how you exactly that's the formula you find your D. You take the two numbers you know and divide by the difference between the two. It's pretty much the ratio of it, or the average. So do we know A1? Can we find A1? Yeah, since we know the difference is 4, so if we take 11 minus 4, we get what? So that's got to be our first term. So the 100th term is 7 plus 100 minus 1 times 4. So it's 7 plus 396 403. Let's do a geometric one. If a geometric sequence has 3 as its first term and a common ratio of square root of 2, find the 10th term. So since geometric, what's the formula for geometric? Very good. We know what n is what? 10. It's the 10th term. R is and A1 is 3. So we know 3 times root 2 times 10 minus 1. And we go further this, but since we know that square root, to get rid of that, we need to have powers of even powers to get rid of the root. We know there's 4 of those, so we have because if we had 9 square roots of 2, every pair of those becomes a 2. And then we have 2 to the 4th is 16. So it's 48 root 2. That's the 10th term. And there's one more sequence that you'll all have probably heard, if not seen in a movie. The Fibonacci sequence. This one's tough because it's neither arithmetic nor geometric. Because the Fibonacci sequence, the way it's set up is it takes two numbers, adds them together, that gives you the next number. Then you take the previous two numbers, add them together, get the next number. So, for example, 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on and so forth. This one's going to be tough. This is the Fibonacci sequence. So you see 1 plus 1 equals 2. 1 plus 2 equals 3. 2 plus 3 equals 5, and so on and so forth. But you see why it's not arithmetic, because it's not a common difference. It's not a common ratio, but it is a sequence. So these are the anomalies of sequences. So frequencies can happen everywhere. And look at example 5. You don't have to have numbers to have equations. You can have pictures to define. If you came in late, it's right here. So we have a circle and a flower that equals $8. We have a watermelon and a flower that equals $9. And we have a watermelon and a cantaloupe that equals $7. How much do they each cost? So how do we figure this out? Well, we know that the circle plus the flower equals $8. We know the watermelon plus the flower equals $9. And then we also know that the watermelon plus the circle equals $7. Yeah, you have to figure out how to figure out what's the cost of each one. So the objective is this. You could only have one unknown in an equation to solve for it. So what do we do here? Let's look at the first one. Let's solve for the flower. So that equals 8 minus the circle. Let's look at this last one. Let's solve for the watermelon. Why did I do that? Because now I can take both of these and plug them into the middle one. A watermelon is 7 minus the circle, plus the flower, which is 8 minus the circle, and that equals 9. No, no, it's 8. So it's circle, it's the flower. No, it's 8 minus the circle. So we have 8 plus 7 is 15 minus 2. Yeah, I get these. So now I'm solving now for the cantaloupe. So I subtract 15 from both sides. So -2 cantaloupes equals -6. I'm solving for cantaloupe, so I get rid of the negative sign. I just change the signs across the board. That one's gone, that one's gone. And divide by 2. So the cantaloupe costs $3 a piece. So in this first one, we have a cantaloupe plus the flower equals $8. So 3 plus the flower equals 8. Subtract by 3. And I know the flower cost $5. So that means in the middle one, I have a watermelon plus a flower equals 9. The watermelon plus 5 equals 9. Subtract by 5. So the watermelon cost 4. So we have the prices of each one of our objects now. Again, you don't need numbers to begin with. You don't need equations to begin with. You can make them with diagrams. But the objective is you can only solve an equation if there is only one unknown. If there's more than one unknown, then you have to find the relationship between that unknown and the other values.